And welcome to Using the FLaNK Stack for Edge AI. I'm Tim Spann. I'm a Principal Data Flow Field Engineer at Cloudera. I like to work in the community in meetups and writing articles, doing events, putting out some open source code in there, especially examples and demos. And today I'm talking about my favorite subject, which is using my three favorite streaming tools together to make things easy and fast, taking data from some devices, using MiNiFi and NiFi to get that into Kafka so we could do some more processing in Flink. And in this case, it's going back into Kafka, back into NiFi, and I'm putting it into a real-time data mart with Apache Kudu. If you're interested in attending meetups, they're all virtual now, so it doesn't matter where you are in the world. If the time doesn't work for you, you could join at your convenience and see everything that we've done in the past in YouTube if you don't have to be there when we're there. And right now, we're not doing things in person. I want to talk about what Cloudera does with Flink. We support deploying Flink, whether in the public cloud or on on-premise data stores. We have 2 PMC members at Cloudera now. The first year we had started working with Flink, we started out how we can integrate with our existing platform because we've had, a data platform for a number of years, so it's pretty robust. So we wanted to bring Flink into that infrastructure. So we connected to our Schema registry, made sure it worked well with Apache HBase and Kudu, and made sure it worked with security and Knox, and had governance with Atlas. We also have been working in the community with blog posts, talks, and of course code. Now this year, we're working on ease of use, simplicity, like I mentioned with the FLaNK stack. A lot of that's coming through SQL, which is a much easier way to interact with something as complex as stream processing, and as well as getting things running easier with Kubernetes. This is some information from our earlier this year talk, so you could check that out if you want to learn a little more on what Cloudera has done with Flink. Today, my demo fits within this rough reference architecture. At the edge, I have a MiNiFi agent collecting some sensors, some IoT data, some energy data, and it's going to send that into NiFi. And then from NiFi, I'm doing some routing, cleanup, aggregation, enrichment. Then I push some of these data streams into Kafka. From Kafka, I have a Flink SQL app that's doing additional processing. And when it's done, it pushes it also to a Kafka topic. NiFi is storing it. Nice little example of using what I call a FLaNK application. Now, the way these work together really helps form a complete connected data lifecycle. So you have that data from its birth, comes into the system. Now we could rapidly put it at storage, have it at rest. This is something we've been doing for years. You have that data, it gets stored, and then maybe it'll trigger, or we'll have an hourly Spark job that runs some data engineering on it, whether that's ELT, ETL, get that cleaned up and ready for a report that you might have in a data warehouse, push some of the aggregate data to an operational data store like HBase, and then use that data to help with machine learning models. What's nice now is we can enhance that. We have data coming into the system, gets buffered by Kafka, which can be used by some of those Spark applications. And we've got NiFi enriching it, which can update those data warehouses so they have more current information as it's coming into the stream. And then Flink obviously can be updating HBase and those operational data sets with new insights that it has from its analysis on that real-time data. And Flink, as well as other tools in our stream, can help update the models in our machine learning and AI, and also use that to get real-time scoring happening on these events as they're in stream. And we can interact with these models at any part of the streaming data pipeline. Now, one thing that's important in this is we have one schema registry. This unified schema management means NiFi, Kafka, and Flink all know what I'm talking about when I put an event on the stream. So NiFi knows this is an energy record. Kafka knows that. So does Flink. They're on the same page. They use the same catalog. It makes it easy for me doing queries. I don't have to redefine what this data is in multiple places where that could lead to security problems, duplications, errors. One schema for everybody. Underneath it all, same lineage with Apache Atlas, so I know what's going on in the stream. I know who's touching a process, how it's being worked on. That makes things very easy for you. Now, I've come up with the term FLaNK, which stands for Flink and NiFi and Kafka. It's really a process where I use NiFi for what it does best, Kafka for what it does best, and Flink for what it does extremely well, is have NiFi grab the flows of data, get it into the data pipeline, Kafka be my buffer for that so it could be distributed to wherever it needs to be, whether that's in the public cloud, a hybrid cloud, on-premise, how many consumers I need to read from it, have that buffered there, and then Flink reading that data in a fast stream from Kafka, doing whatever it needs to do. With me, it's usually Flink SQL, do whatever analytics it needs to do, push that to another Kafka topic or to, say, HDFS or an object store, and then I've got this streaming data pipeline that works at these fast events where they all have standard lineage, standard schemas. It makes for a very simple way to do these things. That's where I came up with the idea of FLaNK. And as you see here in our data in motion platform, that fits our three main boxes with that underlying layer of SDX for security, governance, single sign-on, management, monitoring. Things that you want to have, but you don't want to have to learn it 3 times. So the same login for NiFi and in the Flink dashboards and in Kafka and SMM, our Kafka monitoring and management tool. It makes it very easy for developers. You just write your apps. I'm not concerned with, learning all these different tools and trying to get them to work together. They're designed to work together really well. And the best place to run these FLaNK apps is in the public cloud. Cloudera has a web service CDP. Our data platform lets you quickly spin up in your environment NiFi data hubs, Kafka data hubs, Flink data hubs. And in that same environment, I could add a real-time data mart with Kudu or a data warehouse, so I can have my data and my data engines that are sitting on the object stores interacting with these streams, run them as long as I need to, then shut them down when I'm done, save those resources, but not taking any shortcuts there, not losing any of the security, not losing the metadata, still having that one schema and security there. It just makes it faster and easier for me. This is a really nice way to develop these streaming apps very quickly and easily and make them scalable. Now, why are we using NiFi? NiFi is really my means of acquiring and delivering this data. Sure, you could do that in other means, but NiFi does this very easily, quickly, and it isn't tied to one kind of source of data. It doesn't just do logs, doesn't just do sensors, doesn't just do databases. It is flexible for so many different sources and expandable for you to do that. And it makes it very easy for you to move this data in a quick manner up until other cloud stores, or as we see in the FLaNK stack, into Kafka for additional processing. NiFi has all the features that you really need to do a lot of this easy data ingestion and transformation, works with that standard schema registry we mentioned, so I can get that raw data in there, clean it up, validate it against a schema, make sure this data is right, and it goes where I want it to go. I push that into a Kafka topic so other people can get that and work on it. And it's easy to use, all graphical, but it's powerful and very scalable. Still has guaranteed delivery and has a full provenance, so I know everything I did to that data. Has all the tools you need for doing, real development with version control and DevOps. So this is a great first piece of the puzzle. And as you've seen out there, it's very scalable. So this is we're not taking any shortcuts to get this data easily. You can get as much data as you need to and get that into your Kafka buffers before it goes into Flink. Now in the middle, very important, is Kafka. We have our own Kafka here at Cloudera. We've added some tools and support for the latest technology around Apache open source Kafka with our schema registry in there. We've got full SDX for security with Ranger, and we've added cruise control so we get smart balancing of our cluster and self-healing, so you don't really have to worry about how much data I'm pushing through Kafka. If I have to bring up nodes, bring them down, is a broker running? Did I just move things? The platform helps take care of that for you. More importantly, today we're at Flink Forward. So Flink, we have support for Flink SQL. We include a Flink SQL client there. We've got it hooked into Atlas, so you get that lineage you want to see. And we've got a nice dashboard so you can see those jobs running. We'll show you all that. I have some slides here after this, so you can take those home, that show you some of the static pieces of the demo. After I show you this slide, I want to jump into the live demo. But this gives you an idea of what's going to happen. Grabbing a couple of sensors from my desk behind me, bringing them into private cloud instance of NiFi. I'm going to push them to a couple of places. Use a schema for the schema registry, get them into Flink, get them into some dashboards, and then we can do everything that we're looking to do with the application. First off, let's go into NiFi. This is a local version of NiFi that's receiving data from these MiNiFi agents. Now, we're not here to show you about MiNiFi, but I want to just show you I have data coming in from MiNiFi, and we could take a look as it's streaming in. This is part of that provenance and lineage I mentioned. And I can see, okay, data's coming in. This one is where that file is coming from, so I know that's from a sensor log. So I know that's some of the environment data. Let's go and see that processing. Again, routing, transformation, enrichment. I'm looking at a bunch of different sources of data coming in. One is energy. I'm bringing energy data over here, and I'm doing a routing on it using a SQL query. Here, I'm looking at the data, figuring out the type, doing a select on it, and sending it to different Kafka topics based on one of the attributes. And then the other way for the environment data, which is sensor readings, doing the same thing, but I have a couple of different queries. We could take a look. I'm sending every record that comes in, regardless of what type it is. Over here, very simple. I'm just going to send this to Kafka. It's pretty easy for me to do. Don't really have to do anything special. This special annotation means it's a parameter. I have that in my parameter store. Here, I'm going to take that JSON in, using the schema to let me know what all the fields should be. And then I'm going to write it out as Avro using that same schema. I'm going to pass those attributes in as headers so that everyone who gets it after this will know what schema is associated with that. So you saw we had two different schemas there. I have one that is for SCADA. These are those energy fields I mentioned. This is our schema registry. Only have one version of this, but it changes. I'll have another. If I need to have multiple, NiFi can handle that. I put some things in here so some of these values are nullable. We don't always get our values. So that is how we get the data. Now we also have another set of data for energy. Different columns there because that's coming from a different sensor. but just to show you that. And then this one will come apparent once you see what we're doing with the data. So as you saw, I pushed it into Kafka. Let's see if we're starting to get that data. I'll go into Kafka. This is the last 6 hours worth of data. Let's first look at the SCADA topic, which is getting those sensor readings. Here I can quickly see that a lot of messages have been coming in recently, coming from that SCADA data remote, which is that NiFi producer, and I have a couple people reading it. One's NiFi, one says connect. So I'll show you what that connect is in a minute, but let's look at this data. That doesn't look very pleasant to look at. That's because that's in Avro, like we mentioned. So I'll pick that this type is Avro, matches up to my schema. So now I can read this easily and say, okay, these are the fields that came in. Great, there's a timestamp. There's a unique ID. There's looks like some sensor values. It's nice. Here's a key. Here's a timestamp, offset. All the things you expect to have in Kafka. Now we mentioned when we looked here, we could see who's reading this data. One of them is NiFi. We'll show you that app that's running in my private cloud. And then we'll take a look at this Connect connector. This guy is reading it here. This is a Kafka Connect app. And he's just pushing it to HDFS, just showing having that one schema and putting into Kafka has purpose. Because now I can move that data and have multiple people read it. Here's that topic for energy. There was an alert because we haven't sent a lot of data. I can put alerts on any condition I want. Again, I have a Kafka Connect app to read it, and I've got a NiFi app. Here, same idea. It's Avro. Easy to format it. So we've got data coming in to our Kafka topics at a regular clip. That's great. We saw we had schemas. We could take a look over here and see what that lineage is in Atlas. Pretty simple. We see it getting consumed by Kudu, and we can take a look at that. We also have the same for energy, same idea. Pretty straightforward. We have the same for this other one, global sensor events, which I haven't shown you yet. But let's show you the second step in this. I mentioned very often NiFi will be in a couple of spots, same with Kafka. Let's zoom in. So what we're doing here is I'm loading those energy messages, pushing them to a real-time data mart in Kudu, and then checking to see if there's an error. I'm going to retry that. Now, I'm doing the same with the SCADA. Very easy for me to do that. It just runs. I just have to really put a Kudu table name here, and now it gets pushed. And we were reading it from Avro. I converted it to JSON, makes it easy. Now, also, I'm consuming from this global sensor topic and doing the same thing with a push to Kudu. Now, why am I doing that? I'll show you the Flink bit in a minute, but I wanted to show you that we're actually getting that data into Kudu, so we can run it and see what the most recent one is. And here's the timestamp. That just happened, and we can look and see as the data comes in, and we get a lot of data. Same thing with our SCADA data that we're putting in sensor records. These just keep coming in, and we get different values. I could do reports on these, whatever I want to do. But let's show what we're doing with Flink. So how do we do that? Let's go to the Flink dashboard and show you my running Flink app. It's been running for a little under an hour here, and we could see the different components. Now this is the source one, as you see here, which Kafka topic that is. And then we have the other Kafka topic for SCADA. As you can see here down in the bottom, we can see how many records have matched, and then they get inserted into this third Kafka topic. You can't get much easier for having an application that joins two Kafka topics on a value or in any conditions you need. Could be in over time, lots of different things you could do there, and it gets inserted into another Kafka topic. We have that Kafka topic over here. This is that global sensor events. A lot of data coming in. And as you see here, again, it's Avro. I didn't have to do anything. I have that schema that we showed you over here. That schema ties in to show the different values from those that are joined together. Now we could easily read that in different types of apps. I could have had a Kafka Connect app, but I have a NiFi app that reads it, pushes it to its own Kudu table. So here I could query that and get my results. It's a nice way to get your data all in one area. And then I have a little visual app here that I could see my data in a dashboard, share that with people, and however they want to see these reports. So that is a very simple way to combine all of them together. And then, we could still connect to the Flink SQL client. It's very straightforward to do. And then I can run my queries. And then we'll add another query here. Let's just connect to our platform. And then we'll be able to query. I think we had something crashed here. But no matter, it's very easy to connect to Flink SQL client. I'm just going to go to my directory. Everyone loves seeing people type. And we'll run this. And we'll have our Flink dashboard up. And the first thing I'll show you that we mentioned integration. So we have a bunch of catalogs here in the Flink SQL client. I'm going to use the catalog called registry. This is that schema registry that we mentioned. I have this tied in a YAML configuration file. And we can see what tables are available. As you see, there's a bunch of them. We have a lot of schemas. I'm just going to do a simple SQL statement here to look at the events. This is the one that we're populating with that insert statement. Very straightforward, but makes for an easy way for you to get that data. And we can see that data is coming in. And if I want to see the details, I could just open it up, see everything that's going on. Now, when we do Kafka here, we can make the decision to go earliest to show you as much as that's in the topic or the latest, so just what's in there. So if I look here, I can look at all these previous pages of data. I like to do that, so I like to pick earliest. This makes also for a nice feature if I want to see how the data has been changing over time. Gives me a great way to see the data in flight. Very nice. And now you see here we have two running jobs. One is that simple SQL statement, and this is just running. At the same time, we have the more important job that's doing the processing and insert of that data. And we can see that's continuously running as we get more data in here. I'm going to show you how easy this was in NiFi. I have data coming from logs that comes in as JSON. If you look here, I can see so much information about that data. When it came in, I've got a unique ID on it. I've got all the timestamps, and I can also view that data that just came in. So if I need to troubleshoot anything, I can see some of the values, and I'll know that later what it matches up to. I get that unique ID. I make that the Kafka ID, so it's easy for me to track. Very easy process for me to take data and push it into Kafka. I don't need to build any class for it. I don't have to need to redeploy anything, do any builds. I just drop these processors on the screen, and if I needed to push it somewhere else, I could push it somewhere else. Anything that has a record, I could just use those schemas. I don't have to write any special logic to take that and store it somewhere. And the advantage of having these records is I can easily do queries on them. So here I could just look at one of the fields or multiple of the fields. I could do a min, a max. This is using Apache Calcite, so the SQL is pretty rich. If I don't know what that schema is, I can infer that. NiFi will take a look at the JSON and tell me what it thinks it is. Same with CSV and XML. But if you have that schema, it's perfect because this schema will let Kafka connect, will let Spark apps, Flink apps custom apps that you write know what those fields are. So in environments where it's a little harder, where you have to write things by hand, having these schemas is very important. That makes it easier life for you. So if we look back here, we show you where we were in this picture. Again, we have all that stored for you. So if you need to come back and look at the slides, you can see that. So we had those sensor values coming in. We have a little MiNiFi app running on these edge devices, grabbing that sensor data, whether that's from syslog or from a file or from a Python API or from Edge AI thing like Movidius or Coral. We do that analytics at the edge, comes into NiFi securely. NiFi is making that validation and transformation, uses the schema to validate and have that from the schema registries that everyone can use it, gets that data into Kafka topics, and that can be used by Kafka Connect apps or other apps as we mentioned. And here Flink SQL is doing a simple join there so that we can aggregate that data into another Kafka topic and use that for whatever means we need to. And this is all under one login, one set of security, whether that's running in public cloud, in private cloud, wherever you need to run, we have this environment ready for you. And it makes it very easy to do these streaming apps, at scale with very little resources to do that. Reading from Kafka, pushing to a real-time data mart. I just push a statement here of what I'm going to do with the data, something to read the data. Again, the configuration of this is very simple. I'm just looking at that schema registry and telling NiFi where the name of the schema is so that it can look here, look by name, and look by schema version. As you see here, I just have one version. If I wanted to edit this and add something else, I can do that. If there's some change that makes sense, I can add another field, and then there'll be two versions, and then we'll use the two versions. Yeah, I don't have a default. If you have a new value that no one has, you have to add a default. So this is doing the validation for you. This is helpful when you're doing applications that need to change. You don't have to worry if you're going to put a new schema in there and break it. You also have options of switching between the different branches of that, doing version control and validating between different versions of a schema. Very straightforward to do that. Again, when you looked at Flink down here, there's no mention when I show the tables that this is a schema register. I didn't have to manually create anything, and I could just describe those tables, see the columns and the types. This makes it very easy for me to just use that schema to know how to do a SQL query. This is very helpful. So if I wanted to do a different query, look at a different table, it becomes very trivial. As long as I have that schema for it, everyone gets to share it. So like I said, with the FLaNK stack, start off in NiFi, push it into Kafka so that we have that data, and then use the schema registry so everyone's on the same page. We have that same contract for the data. What are the fields? What are their types? Are they nullable? What do they look like? Do that. Have Atlas underneath looking at everything going on here with all my Kafka topics so we can see multiple steps happening. Like some of them have a lot of different steps depending on what you're doing. For ours, it's pretty straightforward. I just need to consume and store. And then once I have it in my real-time data mart, I could do my queries and analytics. Very straightforward to get that data very fast, no matter how much of this time series style data I push into it. And then I could spin up visual applications on top of that and see all the data as it comes in. make that available in reports that people like to see, and have that constantly updated as we get more data coming in from Kafka through Flink into this other one. I want to leave enough time for everyone so we can have question and answers. I'm sure as Flink people, the Flink part is pretty straightforward for you, but that connection with NiFi and Kafka, that might be all new to you. So let's leave some time for questions, and I'll end up here on some slides. Let me show you how you can get more information on what we're doing. I put everything I've written in a couple of different Git repos so that if you want to run this on your own, you can. I've got all the scripts to build, all the assets in here, whether it's tables or SQL queries, whatever it is, that's documented here, and I have a script that'll build that up for you. I also have links to our tutorials and some demos I have out there, just so you can give it a try. Thanks for coming to the talk. I'm hoping people have questions. Otherwise, I'm going to dive through the demo for you, show you some other pieces. Thanks for coming to my talk. I hope you've gained some interest in FLaNK and appreciate how NiFi, Kafka, and Flink work together as super friends.